Let's have a look at Windows Azure tables. So a storage account can create as many tables as you need, and a single table can store even billions or trillions of rows, and then can contain terabytes of data. And all this data would be stored distributedly, and you'll get better throughput because the data would be reside in different nodes. So in the Azure table, the Azure table is a collection of entities. So you can think of entity as a row. And then each of these entities can have a set of properties. So you can think of these properties as columns in our traditional table terminology. When we look at the Azure tables, there are two key properties you have. So the combination of these two key properties creates the primary key for these tables. So those would be the partition key and the row key. So the combination of these two would form the primary key for that row. And whenever you query the Azure table, if you're going to query it based on the partition key or row key, then your queries would be much faster. But other than using other columns in your table. So there are ways to, if you go ahead and try to use Azure tables, there are a lot of ways where you can encode a lot of information in these row keys so that you can do many queries efficiently. And then, so the partition key serves another purpose as well. So the partition key serves, it enables, so whatever you have with the same partition key in a table would be stored in a single node. So when you have different partition keys, you can make sure that your data is stored distributedly. So this is not a hard and fast guarantee, but so this shows the structure of the Azure tables, similar to the blob storage. And yeah, so the Azure queues provide a queue service, a simple queue service, which can be used to asynchronous work dispatch. So this is, so if you think similar to your traditional queues like the JMS queues and etc., they provide delivery guarantees like exactly once. But if you look at the Azure queues, the guarantee it provides is the delivery of at least once. So that means your message will be delivered at least once to a worker at some day, at some time. But it's not guaranteed that it won't be delivered to two workers. So a message can be retrieved by multiple workers at the time. So whenever you deploy, whenever you develop applications using Azure queues, you have to take care of, make sure that these things won't cause issues for your applications. Another feature the queue supports is whenever you pull item out, it won't delete it. It will just make it invisible. So unless the worker who pulls it out deletes it. So this is a very good feature, because we can use this to implement fault tolerance. So if a worker picks up item from the queue and starts executing it, and then it fails or the node goes down, and then whenever that visibility time expires, the message will be once again visible in the queue. So another worker can pick it up and do the execution. So this is like a very simple fault. You can use it as a very simple fault tolerance mechanism. So yeah, so this is a simple application you can think. This is a very simple MEC-based web application. So in here, the application is, you have a set of PowerPoints, and you are creating a service where the users would upload PowerPoints, and then the service will go through the PowerPoints and see is there any branding violations. So this is like if you have Azure in the slides, to make sure that it's always associated with Windows Azure or SQL Azure, things like that. So, so you have web roles, which takes care of the front end, and the user goes to the web role and uploads the slide, and then the web role will get it. And then the web role will upload the slide to put the slide to the blob storage. And then it will also create a placeholder in the blob storage to store the results of the processing. And then it will create a queue message and put it into the queue. So there would be several worker roles listening to the queue. So these would be the worker roles who are responsible for going through this presentation and then figuring out is there any issues. So these worker roles will pick the message from the queue and then will start processing. And then we'll pick the slideshow, the presentation from the blob storage, and we'll process, and then write the output to the placeholder. And then finally, the web role will give it back to the user. So this is a very simple web application you can develop using Azure. Yeah. So now we'll go ahead and look at, have a brief overview about the other building blocks we have in Azure. So one is the SQL database service called SQL Azure. So this provides Microsoft SQL Server as a service in the cloud. And then we also have a caching service. So when you have multiple rows deployed in the Azure, you can use this cache service as a distributed cache. So for example, if you have 10 instances deployed, and then each of the instances have 2 GB of RAM, and then when you use cache, you'll get aggregate caching capacity of 20 GBs, so which you can use. So this is similar to the objective of Memcache. So another service is the identity service. So you can think of this as Active Directory as a service. So you can use this for authentication and those kind of purposes. And then Azure also provides a service bus, which you can use to provide messaging between your applications. So this service bus supports multiple formats of data. So let's move into the Azure HPC Scheduler, so which I think might be the most interesting for this audience. So the Azure also provides hosting of Windows HPC Scheduler in the cloud. So you can go ahead and request a HPC cluster totally deployed in cloud. And then even the HPC Scheduler will be deployed in an Azure instance, and you'll get a web API, you'll get a web UI where you can go and deploy your applications. So this service currently supports parametric sweeps, MPI jobs, linked to HPC computations. So linked to HPC means the previous, the rebranding of the previous Dryad. And so this HPC capability also supports cloud bursting. So for example, let's think you have a Windows Server cluster in your locally in your university or in your company, and then you can configure it to have additional compute resources from the cloud plug into the same cluster. So whenever you submit a job to the HPC scheduler in your local cluster, if your local cluster do not have enough resources, it will automatically provision instances in the cloud and then use them for the computation. Yep. So, if you are thinking of developing applications for cloud, so Microsoft provides the Windows Azure SDK, which is a development environment. So currently it provides it in many languages, so mainly in .NET, and then it provides a Node.js SDK, a Java, Python, PHP, all these APIs are there. So the best thing that comes with this API is the local development emulator. So, so with the local development emulator, you get a compute emulator as well as a storage emulator. So whenever you develop your applications in Visual Studio, you can debug them, you can run and debug them locally in your machine, machine itself. So this helps a lot in terms of developing applications as well as testing. Yeah. So when we were developing with the Twister for Azure MapReduce framework, we've been using the local emulator a lot to test the things. Okay, so that's it for the Windows Azure introduction. So the next up is the Twister for Azure, the introduction to Twister for Azure, the iterative MapReduce runtime for the Windows Azure cloud. And then after that, we'll be having a k-means clustering demo, which we implemented using Twister for Azure, and we will be deploying it in the Azure cloud.